This is a JVC TV, model number L for Love, T for Thomas, 32, C for Cat 675, with a flashing red LED fault. Before I opened up the back and had a good look inside, I thought I would just plug this TV in and switch it on, see if I can see anything that would give me a clue as to what's going wrong with it. And one thing I noticed after a while of standing looking at it, it looked to me as though there was a ghostly image of the television picture actually on the screen, and that kind of alludes to one problem. And I see if we can pick it up on the camera. If I need to put a torch on this, and let's switch to TV. I don't know whether you can see that, but you've got here, I hope it's coming out, you've got here a ghostly image of what should be, I'm wiping the dust off the screen, there's a ghostly image of something written on the screen. So this suggests to me that there is something wrong with the backlighting of this television set. The image has gone off now. So what I'll do next is I'll unplug it, open up the back, and just see if I can see anything wrong with the boards and perhaps capacitors, resistors. Just check a few diodes and check a few capacitors just to make sure that there's nothing untoward there. It's amazing just how little is inside a modern flat screen TV. I've visually checked everywhere and I couldn't see a single thing wrong. I've been looking for burnt board or components that have been overheating. I couldn't see anything. I've checked capacitors to see any bulging cans. None of those. I've checked all diodes. All diodes seem to be working. Resistors seem to be working. So it looks on the face of it as though there's not actually anything wrong with these boards, although I could be mistaken. So it looks as though I need to gain access to the backlights. That's going to be interesting. I did not find removing the face here, the bezel, particularly easy to do. There are many little, I don't know whether you can see it there, many little catches, plastic catches, that with a small screwdriver you have to gently lift off, and you know, take your time, don't rush it, you're going to break something. The screen underneath, the glass screen, is extraordinarily thin and looks very fragile, and you've got to handle that with care. But in the first place, you need to remove or disconnect the single inline connector here. That connects to the glass screen, and the socket is actually mounted to a small board attached to the screen itself. And that socket that has a locking catch. You have to lift that locking catch first before you can actually pull off connector there. Other than that, it went reasonably well, but I'll just reiterate the warning over the glass. It looks extraordinarily fragile. I haven't got it here to show you, but I've actually removed it to a safe place where it will stay propped up until I need it again. I would just like to add that I've actually got this, the printed circuit board. The circuit boards are underneath here still. I haven't removed them. And I've got the TV, the flat screen, mounted on two books either side of sufficient height to defend the circuit boards underneath. And also I haven't fully detached the loudspeaker assembly, the plastic assembly here. I've left it still connected and put it to one side. It's all a bit clumsy to manipulate and move, but and in fact you can see that There's one speaker underneath here still attached to this part, and there's another speaker here which is attached to this loose assembly here. After removing yet another fiddly subframe, I was able to gain access to two white screens. Just before I removed them, I marked very carefully on one of their tabs a mark to polarize, so that when I get to reassemble, I'm able to put them back in exactly the same polarization position. Well, having opened it all up completely, I spent quite a bit of time trying to work out exactly what's wrong with this. And I had a dilemma. I had a suspicion that it's the LEDs, but I wanted to prove it. And I had a dilemma between the power board and the LEDs. The power board, which is this here, has quite a sophisticated LED driver, and I don't have a circuit diagram at all for this television set. And if you turn over there, you've got a surface mount chip here, and it's quite sophisticated, and you can't quite work out whether it's the chip that's at fault, i.e. the replacement of this board is needed, or you could get the chip and replace the chip. But these boards are not very expensive second hand. Or indeed the LED display. The LED driver chip and the LEDs have a very, what I would describe in biology as symbiotic relationship. They depend very much on each other, and the drive chip monitors the quality of the LED output quite closely, and so it will shut down if it senses anything that's wrong with the LEDs. And so therefore, if there's something wrong with the LEDs, the driver chip will shut down and protect the LEDs from further damage. So that loop, is it the chip or is it the LEDs, I wanted for diagnosis to crack and work out which it is. Is it the LEDs or is it the chip? I managed to secure the data sheet for the chip, and incidentally it's called as far as I can see, it's called an MPS 1730, or it has a second number which is MP, that's M for mother, P for Peter, 3398A. And I was able to secure the data sheet, and I put a link to that in the description. So this is my setup to test the LED strips. I've disconnected the wire, the little cable assembly that has two wires in it, to the LED panel, because you don't really want power going back into the circuit. And incidentally, that cable has two wires on it. Naturally, it has a red plus and a black negative. Well, in this case, the black wire is polarity wise positive, and the red lead is negative, or the chip pull down. So that's round the wrong way. Okay, my setup here is I don't have easy mains power to this bench, so in the corner here, in the corner there is a 12-volt battery, and I have a little power supply here. It can supply up to about half an amp, something like that, set to 30 volts. In series with the output, I have a 1k ohm resistor to limit the amount of current that can be delivered to the LEDs. So they're going to be quite dim when I connect up. So what I'll do now is just power up the LED strips. But if your board is in circuit, make sure the cable to the power supply board is disconnected. Right, here's my 2-point with the 30 volts on the ends. They're quite close together. And you see this strip is not powering up at all. And just to demonstrate that this is all working, let's try the top strip. There you go. So the top strip's nicely working. The intermittency there is my bad contact here, but the top strip is okay and the bottom strip is at full. And that is of course the reason why the chip on the power supply board has disconnected itself from the LED display, is simply because it was able to determine, I presume either by over voltage, undercurrent, something similar to that, that one strip was failing, so it completely switched off. And so there we are. That is the fault for this flat screen JVC TV. All I got to do now is purchase a replacement pair of strips. Hopefully I order the right ones. As you can see, the LEDs, the new LED strips, have arrived from a reputable supplier, and they did a very good job at attaching them in delivery to this wooden batten. They put them along the side of the wooden batten and then wrapped it in a cling film and packed it in cardboard, and it survived the journey very well. I'll put a link to that supplier in the description. I'll just remove those. The removal of the old LED strips was a little tough. The perfectly working strip ended up by being destroyed. It had obviously broken a number of LEDs, so that's now useless. The residual material that was stuck onto the metal frame here, I removed. I sort of experimented with a couple of ways. The old LED strips, I levered off with a box knife and a small screwdriver, but to remove the material afterwards, I used something that we call methylated spirits to soften the adhesive that was on the frame here, and I used this rather old device, which is you know, when paint gets stuck on a window, you can remove it quite easily with this. I mean, it's effectively a Stanley knife blade attached to that, and by operating it in this action, I was able to remove the remaining material that was stuck to the frame of the TV. Before I actually stuck the LEDs onto the frame, I tested the new ones with my 30 volt supply with a 1k ohm resistor in series to make sure they actually worked before I stuck them down onto the frame. All I had to do is, on the back of the new LED strips was a blue strip, just remove that and place the strip into the socket almost as far as it will go before you stick it down. And when you're satisfied that that is connecting properly, then carefully, inch by inch, stick the strip down. But I refrain from pushing it down too hard. You kind of need to be gentle with this, or else you could crack and break one of them quite easily, I should imagine. And now for that moment, do they work? Before actually switching it on, I checked that the cables to the LED strips were properly plugged in and that there was nothing untoward. The boards were in a safe position, because bearing in mind you've got mains voltage going to this. And over here on the far right hand side, there is the connector that needs to be made to the remote control sensor in the primary, the first frame. And now the moment, give me a moment and I'll switch it on. I should imagine the camera will blank out if they are actually on, because it's a very bright light. So let's just see. I'm switching on now. Nothing, and there we are. I don't think, for the camera's sake, I don't think I should leave that on too long. So it looks as though all is well, and what I've got to do now is start to reassemble it. Testing on the way, I would imagine. I'll now switch on and just check for uniformity of light distribution. And it's only going to switch on for a while. There we are. It looks pretty good to me, quite uniform. I can't see any patterns or grey shady parts. All I've got to do now is fit the second frame back on. Okay, we've got this now assembled with the white screens. Just make sure that you've got the polarization of this correctly. Fortunately, I marked the white screens on the edges here, colour marked each layer. Make sure that they all locate into these little tabs, all locate into these standoffs over the back there. If you've got this wrong, they won't locate properly, so it's polarized. But I was pleased that I color coded each layer, and I've got this red, blue and green being the top, simply because I originally assembled this with the white screens and I forgot one of the screens. And when I went to switch it on, so it's a good job I'm testing it, and incidentally I already put the second frame on. Lovely. When I went to test it, I noticed I was getting two herringbone patterns on the screen itself. So I thought, you know, I've done something wrong with it. And indeed I had. I had forgotten one of the white screens. So I had to dismantle that and correctly assemble the white screens as indicated. Now I shall go and test and see what it looks like. The installation of the first frame went very well and it all seems to be working. I'll just power it up. I haven't got the speakers installed and I haven't got the tuner connected because I didn't want to bump into any copyright issues. And as you can see, the screen had fired up there. The only minor, let me power that off. The only minor issue I had was in respect of the display board mounted here with a little connector. It took me a moment or two to work out how to fit the connector, and after a moment I was able to achieve that. But the mounting pins, the plastic mounting pins that hold the board in, were, to put it bluntly, damaged upon removal. So what I used was two barbecue sticks, because they were very small, and there's a barbecue stick. I cut off the ends, you know, where the sharp bit was, and screwed those in to the holes that hold the board, and it seemed to be working perfectly well. So hopefully that'll do. So I'm pleased with myself. This is all working well. All I've got to do now is install the speakers and the rest of the parts, and hopefully it will continue to work. So what do I not like about the repair of a flat screen television? Well, in principle, it's a non-economic repair, so therefore this has been built to be disposable. Given the fiddly complexities of replacing a backlight LEDs, the method that I adopted, it seems to me plainly obvious that you could have an LED cutout at the back of the metal frame, so all you would have to do is purchase a strip which you attach to, say, a subframe that you then insert into the back of the metal frame. So you'd remove the old one, remove the LED strips, take off the old LED strips, stick on the new LED strip, and then insert it from the back. I see no reason why they couldn't have adopted that method. The only reason why is the fact that they didn't want to adopt that method, and they wanted this product completely disposable. And by the way, you can see what a lovely picture I've got from this TV now.